this hands-on workshop for CAPE, Community AI Platform Engineering. I'm Hasit. I lead platform engineering at Outshift. Outshift is Cisco's incubator. Moving on. So first, when we think about platform engineering and platforms, it's a deliberate bottleneck that has been introduced to streamline and make sense of all the diversity and complexity that has kind of have happened over time with DevOps, microservice architecture, SRE, cloud native exploding with a lot of diversity and capabilities. So we typically put a platform team and platform engineering in order to streamline this bottleneck. However, because of limited automation, tech debt, and even things like cognitive overload, it's very difficult to keep up, and this would lead to slow releases, growing frustration from engineering teams, and also things like not having a competitive platform offering. So what we are trying to do with CAPE is to really redefine platform engineering, leveraging AI and agentic capabilities that are there. And in terms of what it is, it's an open source multi-agent AI system. It's supported by this community called Cloud Native Operational Excellence Community. There are a few enterprises behind that. Primary idea here has been to really figure out how to do certain platform components at scale and share best practices. So we ended up initiating a special interest group in this community around applying AI and agentic AI into the platform engineering domain. And this is kind of where we started. I, in fact, started at Outshift beginning of 2024. We had a lot of challenges with SRE and how SRE was being applied. We embraced platform engineering, and then there was a lot of things happening around agentic AI. So we were thinking how to leverage what was happening around agentic AI as a grassroots effort to help us, be better at what we are doing. There were a couple of small efforts, some exploration, a couple internships. We joined Canoe around the same time. Then one of the big aha moments was we were looking to replace our workflow engine, and we ended up using positioning LangGraph as the workflow engine, and that was hugely successful. So we ended up having a multi-agent system that was successful at Outshift. And obviously in the industry, there was a lot of things happening around MCP, A2A. We have an effort around Internet of Agents called Agency. So with all of these things shaping up, we decided to open source this effort under CAPE as a good example multi-agent system that could allow a community impact in this area. So high level, what we have kind of accomplished in our business unit is we have, developers can interact with the system over 5 user interfaces. So WebEx we use as instant messaging. On our IDP backstage, we have an entry point. You could assign Jira tickets. You could also interact with the system on CLI and VS Code. And in terms of functionality offered by the system, you have things like knowledge-based functionality, so documents, live tool calling, a lot of scattered information that's coming through different systems, feeding into a graph database, so we can do cipher queries, and so agents can get insights from the scattered data. A lot of self-service workflows that we converted and made the entry point to happen through LangGraph. And then there was some other more ambitious work around going from natural language into generative Kubernetes configuration, and being able to allowing developers to quickly iterate on a sandbox around that. And in terms of the impact, we used to have 3 engineers dedicated to a permanent support desk. So we are able to repurpose that time to do innovative and more creative engineering work. In terms of some of the queries, if you're asking something that used to take half a day sometimes, these have been reduced to seconds if the AI system is able to answer those. And certain tasks are end-to-end automated with an agentic workflow, so you don't have to, the developers can get a much better experience and an instant resolution to lower toil tasks. So things like, hey, I need a development VM, I need a LLM key, I need a new GitHub repository set up in the streamlined platform approach. Those type of tasks can be done fully automated. And it's high level numbers here. So today we also have some badges happening around the CAPE effort. So certainly everybody finishing the lab, you'll get an Explorer badge that you can put on your LinkedIn and other places. It's a certified badge through Credly. And obviously, if you decide to get more involved in the community, you can earn these other badges over time. Do get involved in the community. Cape.io is the place to check out the repository and the landing page. We have a meetup every Monday, so you're more than welcome to join there. And also, please do star the GitHub repo to bookmark it and to show your support. It'll be awesome for folks to join and change the future together. So I'm gonna hand over to Sri now, who will introduce you guys to the lab.
Awesome. Thank you, Hasit, and welcome everyone to the CAPE hands-on workshop. This is going to be a fun hands-on exercise to play with CAPE, play with agent building, multi-agent systems, and what we're calling distributed multi-agent systems. So these agents are running as Docker containers. They can be run in not just your local Kubernetes cluster or virtual machine. They can be distributed in any kind of environment and use networking protocols, especially like something like A2A or MCP to connect these agents. So we'll go through all of that. Before we get started, we have packaged all of this workshop into a lab environment, so you don't have to bring any virtual machine, or you can obviously try this on your own, in your lab environment post the lab. This lab is available for you for the next 24 hours. So you can play with CAPE, test different scenarios, bring up and tear down different agents, etc. And we'll go through some of these during the lab. So as Hasit mentioned earlier, so this is the landing page for our repo. So you are looking at github.com CNOE, that's Cloud Native Operational Excellence -IO, and then AI Platform Engineering, that's the landing page for all of Cape. It's a monorepo. We have many packages that we both first party write these agents. In many cases, we're using remote agents. We have platform engineering background, so we are very much packaging Helm charts. We do full CI/CD and follow the best practices of open source as well as platform engineering for building these containers. So, and there is a very comprehensive amount of documentation around Cape, architecture of Cape and solution architecture. We'll go through some of this, touch base on them. And if you want to get started very quickly, we have a quick start guide here. If you are doing it locally in your environment, in your laptop or a VM, you can do that. But in the course of lab, you'll go through some of this in the environment. So if each of you can take a minute to put your email address and the session password, which is all lowercase cape, CAIPE. So one of my coworkers will post it in the chat window. So Sujata just posted the session password. I'll make sure that I also typed it in here. So yeah, you'll get a couple of these. So basically put your email address, preferably your company email address, so you know who attended the labs, just for our own understanding. And then once you put in the password, it'll take your name, so that this information will be used for giving Credly. We don't have any other usage for that information. We're not using that for any kind of marketing. We just want to once you finish the lab, we'll use that for basically issuing the Credly badges. Once you put in the information, you will land here. So this is the lab environment. Each user will get a unique instance, and you'll see at the top right corner there is an expiration for the lab, and this is when the lab will basically self-destruct, auto destroy, and then you won't be able to access the lab. Again, anything you do in the lab is self-contained here, and within the lab environment there is a terminal window, which we'll talk about in the next session too. There is also an IDE interface here, so you can open a VS Code IDE that'll launch, and it'll ask you, which theme you want to select, and basically you can launch the IDE here. You can also look at the browser. There'll be a use case for that, and we'll come back to that in a minute. So I'm going to take away the terminal here for a second and just focus on Cape. So you may be wondering why Cape and how it is pronounced. So Cape, like a superhero cape, kind of a homage to an internal project we did called Jarvis. So Jarvis, there are many Jarvises out there, and it's quite popular. It started out with Iron Man movie, and obviously we wanted to kind of differentiate ourselves as a community-driven AI platform engineering project. And it has slowly evolved, started as a multi-agentic system, but now we're calling it a DMAS, or distributed multi-agentic system. The idea with Cape is that it is a deep agent, which is distributed multi-agent system, that you can plug in any A2A compatible agent. Some of the ones we wrote are the ones with AWS, a lot of Argo apps. In fact, beyond Argo CD, recently part of KubeCon, we did a talk where we've open sourced many Argo workflows, rollouts, and Argo CD. And these MCP servers are auto-generated by one of the tools we wrote, but it's not just pure OpenAPI spec to MCP auto-generation. We've done some enhancements around LLM, tool enhancements, and also conformance to certain LLMs. LLMs have restrictions on how the length of the tool that you can have, the context window, how much tool documentation you can have. So many of the MCP servers are auto-generated by us even before the MCP servers started to come around, the official ones. When the official ones are in public domain, like GitHub, we started immediately using them because we certainly don't want to maintain those MCP servers. So initially we were also concerned about the software supply chain and bill of materials of these MCP servers. Over a period of time, we started to move towards more official ones. So in a nutshell, you can think of Cape as a framework platform that can connect to any combination of bring your own A2S agents, and those agents talking to MCP servers. And we have a prescribed list of A2A agents and MCP servers that we ourselves use internally for our own platform triaging, debugging, and creating self-service workflows. And with that, with the Cape Deep Agent system prompt, you can create multiple personas within that. And I'll flash that real quick, how the Deep Agent system prompt looks. Don't get intimidated by it. It is how many Deep Agent system prompts are written. And it is quite elaborate. We have written a lot of directives, meta prompts, execution plan directives, etc. And this is essentially how we perceive, and I'll drop in a link here in the chat for a Deep Agent prompt so that you all can see and appreciate what Cape is doing ultimately. The idea is that deep agents like platform engineer, incident engineer, or product owner personas can really customize Cape to your needs and whatever your organization needs. And you can use a combination of different domain-specific agents. You may ask, why do multi-agent systems at all? Why can't you put all the tools into one agent? Initially, that's how we started. We started our journey with a simple React reason and act loop agent. We'll cover some of these concepts in just a minute. I'm just setting the background. And we started with simple set of tools for self-service workflows. And then we kind of evolved into multi-agents as our context grew. And we started to see that one single agent cannot scale because your tool context grows, your LLM context grows. The number of tools we were adding to the LLM were in the order of hundreds. So we wanted to isolate that context and then use that multi-agent system architecture along with the supervisor, which is what Cape is, to be able to orchestrate these. Just wanted to last but not least reiterate, open source projects are all about support, community support. We highly encourage you guys to participate, join the community meetings, be in Slack, and last but not least, start the repos so you can follow and bookmark and learn more about Cape. So I'm going to pause here. If everyone can give a yay or nay in the chat, that if you are able to access the lab, that way we know that you actually have access to this lab environment, and we can proceed. I'll just take a 30-second pause. Yeah, thank you. And also, while we're doing that, feel free to introduce yourself. This is a very interactive session. We want this to be super interactive. Ask questions. We have several panelists who will answer the questions live. We would love to hear about your use cases and which company you represent from, so that we know what our reach is and how Cape is reaching different individuals. And if you are just an enthusiast about AI and agents, that's also welcome. We just would love to hear from you. I'm going to take 1 more minute pause, 25 past the hour. It's 1:24 my time. At 1:25, we'll get started here with the AI agent concepts. Yeah, if you have any trouble getting hold of the lab or accessing, please drop a note in the chat. We can organize a breakout session, or someone can work with you one-on-one. Awesome. Thank you, Jerome. Yeah, it's great. I think we are 25 minutes past the hour. We will slowly get started. And then if anyone has any difficulty following the lab, feel free to post a question, or, we can always, one of our panelists can do a breakout session. So let's kind of level set in terms of like what I know many of you have gone through different journeys of agentic multi-agent systems. Just so that we are all on the same page, let's go through some basic AI agent concepts, right? What differentiates a large language model from an AI agent, right? So a large language model, as most of you have experienced this massive revolution that's happening, it the way they are built, they have basically amassed all the information that's available on the internet and to most of humankind at this point, to ingest that and train these generative transformer models. So when users are asked a question, or they are trying to do something, they have enough of general knowledge to be able to answer those questions. So over the course of as the model creators started to notice the behavior of these models, they also realized that these models are really capable of reasoning with natural language. So they can take any natural language question and able to interpret and infer what type of action the large language model can potentially do. And this simple paradigm, what many call in a research paper written by some of the Google scholars, called REACT, Reason and Act, that really became the premise of agentic applications or AI agents. So when you give either a small model or a large language model a question, if it reasons on that question and it can call or invoke a set of functions or tools that are supplied by you, that in a way can create a closed loop where the large language model can continue to reason on the feedback of the tool and basically go in a loop, and that's why it's called a react loop, and continuously do that until it's satisfied with the user question. So there are certain patterns with respect to that. Here we describe agents can plan, execute, look at the feedback, and adapt based on the feedback and go in that continuous loop. So what are some of the components, what we were calling the anatomy of the agent, right? So I think this diagram is a little bit apt to zoom out and look at. So if you look at the core of the agent, you have your typical React loop. You have something called the system prompt, the instructions that you give to the large language model on what type of directives you are telling the agent, the high-level directives you're telling the agent. You also give system the tools that you want the large language model to call. MCP, which is the Model Context Protocol, has become extremely popular. Initially proposed by Anthropic, it's starting to become an industry standard. It's a way to expose all your API calls, like REST API calls, in a standardized way using MCP. So in a typical agent, you have your framework, whether it's your LangGraph or ADK or Strands or CRUL, Llama Index, many of them out there. And these provide that basic React loops. They also have something called memory structures, like where you can manage your message history, your short-term and long-term memory, as well as system prompts, like templating those. And you bind them with the set of tools, right, like MCP tools. That kind of forms the agent core. So again, some of this is very fluid. Folks have developed agents that expose MCP interfaces. A lot of teams have built agents that just consume MCP as the lowest level, like tool interfaces. So there is not a right or wrong way. This is one opinion of creating agents, where an agent consumes an MCP server, but in itself, it's a separate entity that manages context, memory, tools, etc. So in the interest of time, I'm going to move on. We briefly touched on what a React loop is. As I mentioned, a React loop is the basic fundamental building block of building the agents. You have your reason and act loop, and that reason and act loop is the one that the large language model uh, will use to continuously take a user question, reason on it, and act on it. So we are going to do a fun exercise. Before we do that, let me just flash this diagram so you see that reason and act loop in a pictorial way. You have your user query here, large language model that's reasoning on that query, and you have this kind of continuous loop of tools. So because these tools are supplied by us, as in the creator of this agentic system, so you can trust these tools and set the right authentication authorization layer on top of that. So the hands-on fun exercise we'll do is kind of think of, you know, you have like a Mars rover, and you have a set of tools like checking the oxygen level or the battery status of that rover. And these are like basically mock endpoints or simulated functions that can check and give you like a random percentage for oxygen, a random percentage for the battery of the rover. These are just kind of those mock code examples. And when you as a user ask a question, hey, what is the oxygen level or what is the status of the rover? The idea is that the large language model will reason on it, call the right tool, and give the response back. Just to level set in the lab, we have pre-configured an Azure GPT LLM key for you. So you don't need to do anything in the interest of time and like avoiding any setup issues. We have pre-configured the lab. I think if you really can focus on like how the agentic code and cape itself works. So the first step we'll do, as I mentioned, the configuration is pre-done for you. And you can actually, in fact, check that out in your .env file, which will edit that in a future lab. So once you get to this hands-on part and go to step number 2. So as I mentioned earlier, one of the very popular abstractions folks use is called a LangChain libraries. LangChain libraries abstract many LLM providers like OpenAI, Anthropic, or Azure, Gemini, Vertex, Bedrock, and they can provide kind of like a single point interface to be able to switch in and out of LLM. So we're going to use LangChain libraries today. Some of these are for LLM access. LangGraph is the framework we use for building our simple React agent. So if everyone can click on this run in terminal, we made it easy where you can just click the button, almost like a Jupyter notebook style, execute it on the terminal. So I'm going to take a 10-second pause. Feel free to post on the chat if you are unable to execute this. Yep, LangChain is the core framework for LLM applications. LangGraph, there are many out there. ADK, this is one of the ones we started with, but we also use strands in strands in ADK in some of our Cape use cases. But pick your favorite one. And this is another binding for Azure OpenAI. So conveniently, there is a script called simple React agent that's already written for you. And the code is like this, right? It looks like this. And let's look at the code together. So as I described earlier, you're importing some LangChain libraries that have what they call pre-built libraries that can create agents. and then you're importing the bindings for a large language model. We are defining two tools, one for checking the status of the oxygen level of the rover, as well as the battery status. It's just doing a random, integer return, and then it creates a basic, LLM pattern and returns that. We're kind of spending a little bit of time so you understand the basics, and as we accelerate in the next lab, these things will become quite obvious. So if you look at the way this is written here, so this is like a 3 or 4 line easy abstraction or pre-built that LangChain provides to create an agent, providing the large language model object, the tools that the LLM, that you're supplying those tools to the LLM, and you're setting a basic system prompt. Hey, you're on a mission control to Mars. These are some things you can do on the Mars. Then as a user, you're invoking a question. Hey, what's the oxygen level and battery status of the rover? And then you're finally looking at the messages that you get back from the large language model. You're parsing the AI message and displaying the content. So I'm going to go ahead and run this here at the bottom right-hand corner. It's going to run this. I'm going to clear and run this again so that we can see this one more time. So yeah, so this output is just a sample output, but what you can see is that it printed the first message that's in the stack. It went to the oxygen status tool call, printed that message. It got the message from rover, printed that, and combined both of them into basically a summarization. So this is defining tools without an MCP server. MCP has been around maybe a good year or so. Around last September, things started to heat up in that space. Even before that, folks were able to write agents, and you can still write agents without an MCP server. If you just take a function call and, with the right type of annotations, provide that to the LLM. So because MCP is the rage and there are so many popular MCP servers out there, what does MCP do? It pretty much does the same thing, except that it provides a more clear standardized interface. And if you're using an MCP transport called streamable HTTP, you can use JSON RPC as your transport. And it makes it easy to do streaming with your agent and the MCP tool. So that's one of the clear benefits. And we're not going to go deeper into the MCP, but just to show an example here, LangChain provides a binding called MCP adapters. This has been around for several months now. And the idea is that you can take any MCP compatible system that's running either in standard IO in your local desktop or streamable HTTP and be able to connect to your to your agent. One popular library, and it's started with the Anthropic MCP library, and FastMCP started to become the official MCP server, is the FastMCP. Here, we're defining a very simple MCP server. If you observe, the tools are the same. We're just using the MCP tool annotation, and we're creating that MCP server. And then I'm going to go ahead and start that MCP server here. And then it's going to basically run this in standard IO mode. It's not starting a streamable HTTP. So if you run the last program here, that's out at the step that says now start the agent. So this will start the agent, create the LLM object. It will invoke the same exact tools, but if you notice in the parameters, the way we were able to pull these tools is by invoking the standard IO mechanism of pulling the MCP tools. So this lab will be available to you guys, to you folks, and then feel free to play with it even after the workshop, so you get a good grasp if you're unfamiliar with MCP. We wanted to kind of level set what an agent and MCP is. This is one question we want to leave you with. typically there is one question that comes up. What is an agent? What is an MCP server? Sometimes the definitions are blurring, but the way we think of it in CAPE is an agent is kind of like a superset of an MCP server. It has the brains of the operation. It includes your LLM, plus your prompts, plus your tools, and your short-term and long-term memory. And it can orchestrate, whether it's in a supervisor pattern or like a group communication pattern, plan, execute. Your MCP servers primarily provide your tooling interface. They can also provide prompt interfaces with version prompts. And there are a few other resources. If you're doing like meta level tools, you can also provide resources through MCP. So that's where the MCP standard stops. The agent standards and where A2A, where it exposes agents, are a little bit more comprehensive in building the agents. So yeah, definitely, having that separation of agents and MCP servers are beneficial for both consuming external MCPs and agents, and also if you're hosting these MCP servers as HTTP endpoints, you can use all the standardized containers that are out there. Yeah, we will leave you at that. And I am going to pass to Sunny to do the next lab, but we will take a 1-minute break so that you all are situated, finish where you are at, and then we'll go into the multi-agent systems lab. So with that, I'm going to pass it to Sunny.
Awesome. Thank you, Sri. Yeah, let's wait 1 minute, and then in the meantime, I'll start sharing my screen. Cool. So if anyone's done with the current chapter, just click next on the bottom, and then we'll take you to our next chapter. And for the terminal, I would just open up a new terminal and maybe close the one you have just worked on so we can have a fresh start. Yeah, and definitely just let us know in the chat if you have any issues or if you're stuck with any of the tasks, and one of us will bring up a breakout room and discuss with you one-to-one. Cool. In that case, I think we can move on to our next section, which is actually running our open source CAPE system, which is a multi-agent system. So Shri has talked about how you can create a React agent, and that's kind of like the basic, what makes a basic agent today. However, this does have a lot of limitations, as this is quite a simple agent where it starts running out of its capacity once you have more complex tasks, or that needs to run for decent duration of time, or is combining multiple different tasks within one context. So what is better in terms of dealing with more complex tasks is coming up with a multi-agent system mass architecture. So in this diagram, you can see that it basically means that the different agents can communicate with each other, and especially you can utilize with deep research, like deep agent architecture, where the deep agent might have useful tools such as it can come up with to-do list. If anyone has used Claude or AWS QCLI, you would have seen that the agent first comes up with a to-do list, and then we'll be able to basically navigate through each step by step. It also will have sub-agents they can call. It allows you to basically have multiple sub-agents focusing on different tasks instead of having one agent to do 20, 30 different tasks and potentially get confused with different things. And also you can have different system tools and prompts. So the general architecture is quite similar to what she has shown you before. However, now you have multiple agents, and in our architecture for CAPE, we have one supervisor agent that will be directly talking to the user. And this supervisor agent is then connected to multiple sub-agents. In this diagram, you just have 3 sub-agents that's talking to the supervisor agent directly. And each sub-agent has their own tools. In our case, these will be MCP servers that these sub-agents are talking to. And obviously, you can have a more hierarchical supervisor architecture like this diagram as well. And there are some interesting references. A long chain is very big on mass system, so you can check out their documentation as well. But in terms of actually going into more details about CAPE and our mass architecture, is that once again, we have our hierarchical supervisor agent. And in terms of between agent communication, we use A2A, which is something that Google has released. It's basically open protocol that and a way to standardize how agents communicate with each other. And it's a pretty much industry standard currently. Hence, we use them to communicate with supervisor agent and different sub-agents we have. Let me try to click the diagram so it's a bit bigger. So in this example, we have like 2 different sub-agents, PagerDuty, GitHub, but obviously it's not limited to a certain number. You can add numerous agents as much as you want. And all of these sub-agents will be talking to the supervisor agent using A2A. Also, the supervisor agent has a way to evaluate and make sure it's still on the right loop in terms of doing more complex tasks by having the reflection agent as well. So for example, in this case, the PagerDuty agent has its own MCP tool bindings and is going to do a React loop to fetch, for example, who is on call, etc. And same for the GitHub agent. And also for GitHub, because GitHub has their own MCP published, we actually utilize that. So even with MCPs, you'll see that within our repo, some MCPs we have implemented our own. However, if there is open source MCP that is official and available, we'll also utilize that as well. So going into some more architecture overview for this workshop itself. In this chapter, we're going to use 2 different sub-agents combined with the supervisor agent, like the architecture I've just shown you, but it's a lot simpler in our case. So as a user, we'll be using firstly the chat client, which will interact with the agent on the terminal. And afterwards, later on, we have this front end called Agent Forge, which is actually part of Spotify's open source project called Backstage, which is kind of a developer portal. And that's how we currently use our agents internally in our team. And it's as simple as the chat client uses fetches the agent card from the supervisor agent using this well-known agent.json path. And the supervisor agent in this case will be connected to 2 sub-agents. One is for weather and the other one is pet store. So in this case, the agents are once again talking using A2A, and these are connected peer-to-peer, which means the agents will be directly talking to each other rather than having an extra layer in between. Also, before we actually start running the fun systems, just to point out, so these weather and pet store agents are just mock agents. Hence, we actually created like a mock MCP service for both of them. So for the pet store agent, it has populated with mock data for different pet companions. And for the weather agent, we have an MCP server that can actually retrieve the real weather data. So you'll be able to play around at the end of this workshop. Cool. So I guess just before we start actually running some stuff on the lab environment, slightly more details in terms of A2A protocol. As I mentioned earlier, there is the standard to let the agents talk to each other. And this is a consistent way to make sure that the agents can communicate, and there's no, it's easier way to integrate different agents together as well, because making CAPE as open source means we also want to allow other people to bring their existing agent and put it under our supervisor very easily. And having A2A as our communication method makes this a lot easier. And it does utilize this small manifest called agent card. And we will actually be able to see the agent card from the pet store agent and the weather agent as well once we start running this. So without further ado, we'll firstly clone our CAPE Community AI Platform Engineering repository. by just clicking this. So you should be familiar in terms of running things in terminal from Sri's workshop just before. And once it has been cloned, what we're going to firstly do is we're going to copy the .inf example file into .inf. And as used before already, we have already pre-populated these Azure OpenAI credentials. So we're just going to click this, which means it's going to copy these environment variables for OpenAI. We'll be using GPT-4o in our case into our .inf file we just created. And then because everyone's lab environment has different URL, so what we're going to do is we will override the Agent Forge base URL, which is our fancier side of front end. We'll show you, sorry, later on. And we're going to actually make it specific for your lab. So this will depend on your actual lab environment. And once again, this address will be stored in our .inf file. And then finally, .inf file basically is a way to configure what kind of subagents you actually want to enable and connect to the supervisor. So in our workshop, as I mentioned, we're going to enable just the weather and pet store agent and the agent forge in terms of front-end chat client user interface. So what we're going to do here is once again, simply just run in the terminal to enable, set the flag basically for these three variables to true. However, for those people who want to play around with the lab a bit more, if you look at this top right, there's this IDE button. So if you click the IDE button, it basically comes up with a code data very similar to VS Code. For those familiar, obviously you can also just do Vim if you're more familiar with that. But once you come in, you can just say open folder, you can do work, AI platform engineering, for example, and click OK. And you can trust the authors, and you can see you're now in the repo that you just cloned. And there's this .inf.example file and the .inf file that you just created. I won't click it because it already has our credentials populated. However, if you prefer to click the .inf file and check it out this way, you'll be able to see that, for example, enable weather and pet store, these would be set to true, and enable agent forge in our case was already set to true. So this would be the same in your .inf file. Cool. So going back to the terminal, we're now going to use the deploy.sh script to use Docker Compose file. So why not run this in terminal, and I can go through slightly about how we're going to actually run the agents in this case, as it takes a slight amount of time. So it actually does tell you useful information such as what services it has detected and will be running. So if I go back to the IDE, I can actually show you the deploy.sh file that exists here. And what it does is basically it detects the profiles as enabled, and it is just running Docker Compose. So anyone not familiar with Docker Compose is just an easy way to run multiple Docker files, such as our mass architecture, where it requires 3 different Docker images to be pulled for supervisor agent, pet store agent, and weather agent, and be able to bring them up together in the correct order. So this is our Docker Compose file. You can see that it's pulling these images and it has some environment variables set up. So let's go back to terminal. And if I'm going a little too fast, do please take your time to read through the documentation and go through step by step. We'll give you a few minutes at the end of this section to go through them, try some more prompts with the agent once they're running. So, and yeah, it takes a little time to pull the images, but we're nearly there. And then once it finishes pulling all these images, it's going to automatically create the network and start running the containers. So let's give it probably another minute, and then we'll actually confirm the Docker logs for each container to see that they're running. Perfect. So you can see that now here, the container for Backstage Agent Forge, which is our front end, and Agent Pet Store and Agent Weather have all been started. And the supervisor agent has also started, and the supervisor agent starts the last because this is the agent that has to connect to all the sub-agents. Hence, it makes sense to have all the sub-agents to come up first and then bring up the supervisor. However, we do have safety mechanisms in our supervisor agent so that if some sub-agent that should be enabled is not reachable, it will be able to eject it and it will be able to automatically check the reachability of the sub-agents. Awesome. So let's check some container logs. Firstly, we can run docker logs agent pet store. And we do in this see this kind of running A2A server in P2P mode. It tells you the agent URL is, well, at port 8000. So that all looks good. And similarly, agent weather, you see the same, that it is currently running the A2A server in P2P mode. You also see that these get well-known agent card.json, which means that this is supervisor agent actually tried to reach out to pet store and weather agent, both of them, and be able to fetch the agent card and be able to know the details about, okay, what do these agents do? What are the example things, example commands and stuff. Cool. And finally, we are going to now check supervisor agent logs. And for the important part, once again, we want to make sure before we start interacting with these agents is that we see the log message saying Ubicorn is running once again on port 8000. So at the end of the day, in terms of user perspective, only the supervisor agent is the one that's exposed and the user will directly interact with. Cool. So once you have seen that all three agents are running, and indeed you can see that the connectivity is successful, we can move and check on the A2A cards. So as I mentioned earlier, A2A cards are the way for the agents to know the general information about each agent. So for example, port 8002 is where our weather agent is actually exposed to. And you can see that it has things like the description, an AI agent that provides capabilities to perform weather operations, some skills such as description and example commands that you can run, and some useful tags as well. And then you can also fetch similar for the pet store agent. And in this case, it's an AI agent that handles pet inventory, custom orders, user accounts, etc. And once again, you see some example prompts that you can do that is relevant to pet store agent, such as show me what you can do with pets, find available pets in the store. And finally, what's interesting is that now that you're fetching the agent call from the supervisor agent, you'll be able to see that in this case, this actually has example that is kind of combining in a sense. So forecast for San Francisco, which is from weather agent, get available pets by status is from pet store agent. The reason it says AI platform engineer is because our supervisor agent was initially designed to be more of a platform engineer angle. However, the architecture itself is not specific to it. Hence, we can hook on to pet store and weather agent that are more generic and probably more approachable in terms of lab purposes. Great. So now that we checked that all the agent cards are good, we can connect to the multi-agent using the chat CLI. So this might take another like 30 seconds. We're just pulling the image and using UVX. And this is another internal tool we have developed. When you get asked to enter token, just press enter. In our case, we don't need any token. And we have prepared some multi-agent interactions that you can try out, obviously not limited to it, but I'll run a few examples here with you and then give you a few minutes, try it out as well, maybe introduce to the agent 4 GUI as well. So firstly, let's check, okay, what agents are actually available? So it correctly says, okay, currently there are 2 agents available. First is pet store and second is weather, which is exactly what we basically saw from the agent card of these 2 sub-agents. And I will firstly ask, okay, so I'm based in London, so I'm very curious about the 5-day forecast for London. And another useful thing about this chat CLI is it can tell you the task process. As I mentioned earlier, in terms of deep agent, the capabilities are that it can actually come up with a to-do list for tasks that need some breaking down, and it will be able to proceed with each of them. Perfect. And it will also give you activities like what kind of tools it's actually calling and where it's at. So it seems like, London is getting quite cold. I do trust this information. It's quite nicely formatted as well. And now that we've tested weather agents, maybe let's try some pet store agents. Say, okay, get me all the available pets, why not? And once again, it comes out with the task progress and it tells you what kind of tools it's actually calling, whether that's supervisor or the pet store sub agent calling these tools. And the streaming output is literally raw chunks given out from LLM, hence the formatting is quite rough. But once the response is finalized, you can see that nicely formatted final outputs. For example, there's a Labrador Retriever, Chihuahua. I mean, these are mock data, so lots of dogs, why not? Cool, so before I let you guys play around with the agents, I'm going to quickly do Agent Forge UI. So if you click this button, it should be able to then come up with the Agent Forge within our lab environment. And when you're asked to select the sign-in method, just say enter for the guest. And yeah, just click OK. That should be all good. Let's see. It's retrying connection, so let me wait. Oh, this might be a VPN issue. I don't know if anyone else has this issue going, but for now, you should be able to, it should be able to basically do the same kind of a communication, and you can once again interact with the agent. I'm gonna try to get my VPN off. I think I'm on the work network, so I'll come back maybe in like 2 minutes and be able to showcase this to you as well. But in the meantime, if this is also an issue for you, do let us know in the panel chat. If not, feel free to try it out there. But the chat CLI is also there. I'm going to stop sharing for 2 minutes while I figure this out. But should we give everyone like 2-3 minutes in order to try the prompts out? Does that sound good?
Yeah, we'll give 3 minutes, maybe 5 minutes past the hour, then regroup.
Okay, I need to switch my Wi-Fi, so I'll be back in 30 seconds.
Looks like Abhijit has a question. Go ahead, Abhijit, put it on the chat. And if you can't answer it on the chat, then we can open a breakout room for you.
Yeah, if you can post your feedback or any comments on this, so we will have plenty of time to do the Canoe Backstage Lab. So give us a little bit of a minute. So we have a RAG module coming up. We'll spend a short amount of time on that, and then we'll dedicate rest of the session for the Canoe Backstage. So yeah, so there are some questions on that. So yeah, give us a little bit of time. We'll cover that. Yeah, there is a question on extending the lab a little bit longer. Yeah, I think the idea is that these are like big instances. So do reach out to us. We'll work with you to see if we can extend or create a different session for you. But these sessions they can be changed. So these sessions will be terminated. If you can reach out to us either on Slack or Sujata, who when you registered, you would get an email from Sujata. So yeah, reach out to Sujata and let us know if you need the lab extended. Also, everything we mentioned here is all in the getting started page. So I'm going to drop in a link there. So you are welcome to try this on your MacBook or Linux box. We have not tried it on Windows, so I would I would not say that it will work or will not work, but definitely your Mac or Linux would be ideal place. Also, we have Kubernetes Helm charts. So we are in deployed to our production, and we have some of our sister teams and few companies who are trying it out. So we would love if you try it out and give us feedback. Time cluster or any cloud-based distribution like EKS or AKS or GKE. So I'm going to pass it back to Sunny. I think she got her environment.
Thank you. Yeah, I just had to switch my network. I have the work-specific Wi-Fi setup, which my laptop automatically connects to. But awesome. So now I'm actually connected because my network has decided to unblock me. And I'll just showcase like maybe one of these slightly more complex commands. So in this case, we're thinking about the cross-agent scenarios. So I'm asking, is it going to rain in Tokyo tomorrow? And also a summary of pets by status. So now supervisor agent should correctly recognize that it needs to reach out to both weather and pastoral agent. And in this case, the two tasks are independent of each other, hence the execution mode will be parallel. However, there might be cases where the agent decides to do the execution in series if it's a task that you need to first fetch the data, for example, from the weather agent about the weather, and then use that info to fetch something from the pet agent. And here the final result is that tomorrow in Tokyo, it will be quite warm actually. 17 degrees is unexpectedly warm. And also there are 15 pets in total currently in the store. So it's actually really helpful to use the execution plans. So it does collapse automatically once the task has finished, but you can always just open up and see, and it does update as it goes along. And also you can see the streamed output, which is the raw chunk data that is streamed out from supervisor agent as well as the sub agents. But yeah, other than that, I don't know if you want to give another few minutes, or I can just pass it on to Shivam as well for RAG.
Just real quick, could you zoom in or put it in full screen so folks can see the plugin?
Oh, you mean the Agent Forge, right?
Yeah. Maybe collapse your. Yeah, there you go. Thanks.
Yeah, no
Awesome.
problem. I might collapse the streamed output, and maybe I'll collapse.
Yeah, for
execute.
folks, this is an open source plugin that the Cape team open sourced. It's available as an NPM package. If you are a consumer of Backstage for internal developer portal, yeah, there it is. You can get it. And honestly, any A2A compatible agent can work with this. We have support for header-based auth. You can send Backstage token, IDP, like you can retrieve the ID token. We have some of that in our documentation. And a lot of ongoing work is happening. Obviously, the niceties of execution plan streamed output, those are very specific to Cape because Cape system prompt generates them. Your generic A2A agent may not do that, but if you don't have it, the agent or the agent forge will not display it. So that's the way it's built. Awesome. In the interest of time, I think we should move to RAG. Sunny, thank you so much. That's been very insightful. Hope you guys got a good sense of multi-agent systems, how you can run two distributed agents like weather and pet store. We purposefully chose agents that are simple to understand. Now we're going to dive into basically knowledge graphs and knowledge bases. This is core of platform engineering where data is just distributed both in textual, unstructured way and structured way. So Shubham is going to cover that in a detailed way. So take it away. Thanks.
Yeah, thanks, Shri, and thanks, Sunny. So yeah, in this chapter, we're going to go through sort of two agents. One is RAG agent, and as well as one which is GitHub agent. And RAG, which is short for Retrieval Augmented Generation. The idea is that you kind of ingest documentation or anything that you want the agent or the LLM to kind of know before answering a question. So what we're going to do in this chapter is basically we will ingest a web page. We will ingest the agency docs. And what the server is going to do, the RAG server, it will generate the embeddings using the LLM model, and then we're going to do a bit of question and answer with the RAG agent, and basically it will the supervisor agent will query the RAG agent. The RAG agent will embed the question, get the embeddings from the vector database, and then answer to the supervisor agent, who will then answer back. So that's kind of an overview of how this RAG system works, and it's a fairly standard RAG system. And we do have graph RAG, and I'll talk about that a little bit later, but not in this workshop, but it is something that is in CAPE. So to get started, just like the previous chapter, we're gonna make sure that our environment variables and secrets are set. So we'll go through that. Make sure that
sorry to interrupt. I think we do need to instruct folks to turn down their lab. So
yes,
yeah, please do.
Yes. So I'm not sure if there should be, yeah. So if you go to the previous chapter, there should be this stop the containers. Make sure you do that. That way you will stop the previous containers before starting this chapter. Once you have done that, yes, make sure to set all the variables, and then run the CAPE stack. There are two agents that we're going to enable to the flags, which is one is the RAG, one is the GitHub, as well as AgentForge. But we'll turn off weather and pet store. So let's do that. And that should pull the images. In this case, I think I've already pulled the images from before, so it should just start straight away. Yep, it started, and we're gonna wait until the supervisor agent is ready. We can do that by just checking the logs, and I'm gonna do that now. And so yeah, it's still starting, and it should start. Yeah, it should be started now. Let's have a look. No, it still hasn't started. It's still waiting. So we'll give it a bit of time until it gets started. So that should be, let's have a look. Yep, still starting. Yep, okay, now it's started. Yep, the two agents that I mentioned are reachable. It's gonna still, it does a bunch of checks, making sure that everything is reachable and available. Yep, it's cool. Yep, now it should be started. So now I can do this curl command to get the agent card of that supervisor agent like before. And yep, we have all the capabilities and everything. What we also started was the RAG server, which will do the ingestion and the embedding. We also started the UI. And so we're going to use the UI to ingest some documentation. So let me open the UI, and the page will load up on the right pane. And in this case, we will ingest the agency doc. So agency, as she mentioned earlier, is essentially sort of framework that Cisco has donated to Linux Foundation, and there's lots of other companies now getting involved. So I'm just gonna make sure that a sitemap is enabled and then ingest. And what you will see is that it will start ingesting, and it will take a little bit of time, but not too much. One thing is that if it does get stuck somewhere, you can stop the job, and all the ingested documents will still be there. Sometimes it happens if for example, some URLs takes longer to load, and that's fine. Like it's okay. You can carry on. So as you can see, the docs have been ingested. It ingested around 64 pages. That's cool. So for next part, what we're going to do is we're going to go to the Explore tab, and we are going to basically try and, but before that, let me quickly give an explanation. So basically, what the server did is it fetched the URL, it parsed the HTML inside. We do splitting of chunks, so we use the recursive text splitter that LangChain provides. And if it goes beyond a certain amount, it's better to sort of chunk it into multiple sort of chunks, and then do embeddings on those chunks. And then we store it into a vector database, right? So now, once we have a vector database populated with embeddings, we can sort of do a query just on the vector database and see it comes up with some results with similarity score. And yeah, it's all good, all working, no issues. So now what we're going to do is, now that we have the RAG system working, we're going to go back to the terminal, and then we're going to run these agent CLI and just wait for it to run. Yep, and press enter when asked for token. And we're going to just ask it, hey, tell me more about Slim protocol and agency, right? And so what that should do is that should, as you can see, it will try and contact the RAG agent and ask the RAG agent, hey, can you tell me more about CAPE or about agency? And then that should give out an answer. Yep, it's still there. And there you go. So it gave out a nice answer of like what Slim is, and as well as some references to where it found this information. Now what we're going to do is we're going to do a multi-agent interaction. So what we're going to do is we're going to ask the supervisor agent to essentially research about a certain topic and then commit that findings to a GitHub repo. And what the supervisor agent is going to do is coordinate between the two agents. It's going to ask the RAG agent to do the research, and once the research comes back, it will ask the Git agent to kind of commit. So that's what we're going to do now. So let me do that. And this is what the prompt is. So as you can see, once again, it's calling the RAG agent and to do the research on agency. Once it does that, it should then start. It calls the write file to like do the to-dos, like, hey, here's the research I have in its to-do, and then once it has written the findings of the research, it will call the GitHub agent, and then hopefully the GitHub agent will then respond and commit. Yeah. So let's give it a bit of time. While it's doing that, what I can do is I can also show you around the repo. So we have knowledge bases, and the RAG part is inside the knowledge base folder, and you can explore this a bit more. And you can run the RAG system by itself. You can interact with the RAG system by itself and configure it as you would like. There are a couple of sort of document ingesters that we are starting to push. So we have an open pull request where we are actually going to start ingesting things like Slack messages, WebEx messages that will help sort of platform engineer, answer questions and whatnot. So let me go back, and yeah, it's done the full research, and it has also should have committed the repo. So if I go to the repository, and yeah, it has done that. As you can see, it has committed the report, and you can kind of go through the report. Yeah, and that concludes this chapter. And we also have something called GraphRag. So if I quickly go back to the GitHub repo, so what we can do is we can also ingest not just documents, but also things like Kubernetes resources, AWS resources, Backstage components, and there's a different agent called agent ontology that can actually create relations between them. So we store these data in a graph database, and we create these relations automatically. And and then basically that allows the question answer agent, the RAG agent, to kind of have a better understanding of how different domains and different informations are related. And so that kind of improves the understanding of the LLM of the world a bit better. This is all, again, you can try it out and you can play around with it. There's dummy data as well available. There's a Docker Compose here. You can play around. But yeah, that's all. And before you move on to the next chapter, make sure to again stop the containers. But yeah, that's all.
Awesome. Thank you, Shubham. And this has been very insightful. And we did this in on time, record time. I know while you're setting up the next one, Stefan, so I'm going to introduce Stefan. So Stefan is going to walk us through the IDP Builder. So for folks who are not familiar with IDP Builder, it's a tool utility that was created in the Canoe ecosystem to bring up Backstage and other components around it. So Stefan will introduce what it does and go through a full lab around that and how Agent Forge plugin actually runs inside Backstage, not just as a standalone plugin. So without further ado, take it away. Thanks.
Yeah, hi everyone. So see my screen. Yeah, so up to now we, together in the previous section of the workshop, we deploy stuff using Docker Compose, right? Which is a good thing to try things and select only what we need to deploy and so on. We are just presenting right now IDP Builder, which is a very neat utility which allows you to deploy with just one command. You will see you can deploy a cluster on your local PC using it's a kind cluster. And on that cluster, it will deploy things like Argo CD, like Git, Git environment, Keycloak for key management. So everything will be deployed for you, and it will simulate a very close production environment, right? So what it will happen at the end is we deploy this in infrastructure, and then on top of that, we will deploy some application on Argo CD, which will get deployed. And this will be our, our application, our cape, and we will interact with it, right? So before we start, be sure, as Shubham said, so here at the end, just to run this command here, to be sure that we are, you are stopping everything, right? So I didn't do this part of the lab, that's why you'll see there's an error here, but on your side it will stop everything you had. So basically, the way IDP Builder works is, it has a sort of stacks or kind of application compounds which you define what has to be deployed by the utility. We defined one of those, so we modified the base one to also include Cape, and then in the Argo CD and the plugin for Backstage, the Agent Forge, and so on. So I'm just gonna clear here and clone this repository. I will start, and there's a part the middle where the deployments takes part, so it's like it takes about 5 minutes, so we can stop there if you have any questions, and we can resync at that point. So again, as we did before, we are going to modify some of the predefined domains and URLs which are usually used for local deployment on your local PC, to be able to use this remote or remote lab. So I'm just going to change some URLs which are customized for each of your instances. And then that's it. So basically, you see I just cloned the repository. This part is just because we are using a remote. It's a VM in the cloud. But usually I just clone the repository, and the next thing I have to do, I just I need to have the utility, the IDP Builder utility, which can be installed like this, right? So, but the only thing I have to do is just launch this command, right? Which is created these stacks. So what it does, it creates a kind cluster. For you which are not familiar with it, a kind cluster is just it's deploying a Kubernetes cluster on your in a container in your local PC. So it simulates very fast a cluster you can just use, and then on top of that, it deploys everything we discussed before. You will see all the containers, all the pods which are deployed. We're talking about Argo CD, about Vault for secrets management, Keycloak for authentication, and this kind of stuff. It will take a while to see things coming up, And after that, right now it deploys the base layer, so like Argo CD, for example, and then we will have to wait for Argo CD itself to deploy and to run the application we provide to it. Right? So this one will take maybe 2-3 minutes to deploy. And then we will take a look with kubectl or K9S. So you can, while this works, you can start a new terminal if you want, and start K9S, for example. It won't show you anything before everything is run, but it's a useful thing to monitor what's happening while it's happening, right? So yeah, we have to wait. And again, let me know if you have any kind of questions. Again, these utilities, the IDP builder utilities, is try to simplify, all the configuration and installation steps you would need to do, right? Imagine that you need to have a cluster, you need to deploy on this cluster all these kind of, applications, and then after that, you have to use those applications to deploy your final use case, right? So yeah, let's wait. So before it's finished, it doesn't even make sense to start any. So we can just play with it. So you kubectl, I just get nodes. You see that there is a cluster right now deployed. One node cluster, and then okay, we can just use K9S to connect to it. If you don't see anything, it's just because it tries to show the pods in the default namespace, not in all namespaces. So continue to click 0 until you see things happening, right? So basically, you see on the screen there are containers created for you. You should wait until you see a backstage container running, not the backstage dependency. Just the backstage one. Ignore the ones from AI platform engineering. They won't be able to run. They will give an error before we configure them. But all the rest should be up and running. So it takes a little bit of time, as you see here. The script finished, but again, there's also application being deployed by Argo CD itself, right? So yeah, so you see here, again, you can start a new terminal. You can use kubectl to do it. You can use K9S. So I think we put a command here to get all the pods also with kubectl. But again, we still have to wait until things are running. Again, if you don't see anything, K9S, press 0, and you will see now the pods from all namespaces. Turn from default. Yeah, it takes from 5 to 10 minutes to get the things in place, but it's a little amount of time compared to what you would need to do if you would have to install all these things manually, right? And it allows you to test to test your applications before going in production and simulate a very similar environment with a normal CI/CD environment. So yeah, we're almost there. So again, we still have to wait because there's a the application on Argo CD are still in process of being started. So you still have to wait until you see the real backstage. That will be the last one, the real backstage pod, which is being started. So that's right. So it's also explaining here. It's unsealed some secrets, and we will see the backstage. You see that the dependency wait is stopped, and it will start. And again, basically there are two commands. So one is like clone the repository, eventually modify it if you want to enable something or add something to it, as we did with our Agent Forge. And then if you have the IDP builder command, you just create it, right? So and you have a bunch of stacks there, right? So we have the reference implementation from IDP builder itself, and on top of it, we build our own, which adds what's missing. Yeah, it should be ready in a couple of minutes. Is there any other questions in the chat? But
there was a question about Vault pod not coming up. In those circumstances, Stefan, do you recommend restarting Vault, or does it come up on it by itself?
yeah, it should come up by itself, or stop it and restarting it. You can restart the entire stack, but yeah.
So it doesn't hurt to restart, right?
It doesn't hurt to restart, but it also doesn't hurt to wait, because it really takes a while. So the lab expires. You see it. You have a timer here. So basically, it's 24 hours from the time we started. But you have to wait. So it really takes some time. So you see right now I have the backstage pod up and running. So you have to wait until you see this running. And then yeah, you should see also here all the pods are running excluding the ones from the AI platform engineering namespace. We also have this is something we do in the lab itself, because we have some real from a certificate authority, we have some SSL certificates, so we are also pushing them to the cluster itself, so we can use everything with SSL. And then just run this command to take the default Argo CD password. We can start Argo CD by clicking this link here. So you see here, Git is deployed. You see it here, Argo CD, and also Backstage. We'll come back to it. So here it's admin and the password we just retrieved, right? So if you go back to terminal, it's this command here which gave us the password. So if I sign in, I should see the application which were part of the deployment. Let me make it bigger if you want. And also the Vault application, which it's the one at the end. So we see things are in order, except the Canoe stuff here, which is still running the platform engineering, because it's not well configured, right? Not yet configured. So let's go back to the lab. We need to configure some secrets in the Vault, which was just deployed. We have some containers which are some agents which are enabled by default. At least in this exercise, so we use a GitHub agent, we use Argo CD agent to connect to ask Argo CD itself what it's doing and any details, and also the Backstage one, which is also connecting using MCP server to Backstage itself, right? So we are just gonna adding those credentials which are auto-generated by the deployment. We are just gonna add them in the lab. And again, this command should be run after everything is up and running. So those secrets are stored there, and it restarts all the pods in the platform engineering namespace now, because they have the right secrets. So if I go back to these are terminating, and when they come back, they are starting, because now they have the needed secrets to connect to those.
Stefan, there is a question.
Yes.
The LLM secret, did we go past that step? Did we just do that step to create LLM secret? I think if you can explain that.
Yeah, so the LLM secret is, I mean, the LLM credentials are already provided in the lab.
Yeah, I
And
think they're saying that LLM secret is not found, like issue. Did we already do that step, or is that up and coming?
I mean, it's part of this setting up of this envars here, right? So
Got it.
in the
Got it.
envars,
From the
it's
setup
part of this
script.
step. Yeah. So in
Yeah.
this script is doing everything. It looks in the envars which you have in your home, which contains the LLM secrets, right? So and it's pushing them to Vault. Right? So it should happen in this step, or just happen in our step. Right? Now I should see them. They're all running here. Yeah, and I have to, see the password for Keycloak for to authenticate to it. I just copy that. And here you have to take care. So when we open Backstage, we first have to open it because of how it works with iframing and everything in the lab. And Keycloak, we have first to open it in another tab of the browser, right? So when I sign in here, I have to put user1, that's the username, and the password. And then I'm inside, right? So I can just close this one if I want, or I can just go back to the lab. And if I click this button now, I'm inside the, it's easier to see it here, inside Backstage, and I can start the plugin here. If you have smaller monitors, you can just make this one smaller to see it better. And also it helps to click, even if you don't see it, go to the right and click this full screen. So it hides the bar at the left, right? So now I have Backstage with the Agent Forge, what you see on the screen. And then I can just start doing things, and it connects to the agent we just deployed, right? Or the super agent, which is doing exactly what you have seen in the previous steps of the lab. So that super agent, supervisor agent is deployed there, and it takes care of handling all the calls to the different sub agents. Some of them being, you see it's pre-configured with a lot of, Backstage, GitHub, Argo CD. These are specified and deployed by default. It's configurable. We can deploy more. We can deploy, PagerDuty. We can deploy a lot of other, agents which are part of the Cape environment. And you can then just put some specific questions for the super agent and see how it deals with it, right? So it has that it doesn't know the version, but it can ask the agent, right? So this is the see it. It's like it's multi-step, or it also has a context, right? So yes, please. And now it should connect to the Argo CD agent and give us the version of it, right? So let's wait for the answer. And you see now it knows the version of Argo CD, or you can, interact with any of the others. That's for the sake of, trying more, see how it works. But yeah, basically the idea is that all the stack we deployed is now being interrogated by those. Let's see from Backstage. It's the supervisor agent interacts with all these tools, which I think the Backstage one is not really responsive right now, or we have a lot of people using the same. Let's try the GitHub one. Or I have to be more narrow in my question, right? So let's see. Let's see if the GitHub one works, right? But basically, the structure and the things happening right now are exactly what was explained in the previous parts of the lab. So how the super agent it's also happening that all of us are using the same LLM key right now at the same time, so it's it might give some problems, but usually it should. Yeah, I don't know. We don't have any so but organizations.
Yeah, you can also try canoe.io or something like that.
Yes. Yeah, something is the connection with the GitHub is not like.
You can potentially ask like, give me my people profile details. I think this is just generic account, so I might still be able to fetch something like that.
Okay. Give
Because
me
when I
mine.
use my, yeah, give me my profile details, something like that. Let's see. Another thing is, I guess, if anyone has is interested, you can replace this GitHub token with your GitHub personal access token that you can get it from your GitHub profile. And with that one, you can actually find things about your actual repo, your actual profile, and all those informations there. Yeah, there you go.
Yeah, and the
so
cool thing is it's using the GitHub Copilot MCP. So pretty much as Sunny said, you could do a lot of things with your own token, open issues, create PRs or approve them. Yeah, it's pretty neat, nifty. Yeah. Go ahead. Steve.
yeah, I was just trying to say we for the sake of the interest of time and also for the simplicity of using the lab, we provided with predefined LLM keys with predefined GitHub access tokens, so we all use the same right now. This might get to using generic accounts is be. Again, if you want to customize it, you have it. You have this lab for another 24 hours. So otherwise, we have the lab guy, which you can do it on your own PC. If you want to access the lab again, if you close the browser, whatever, you have to go back to labs.outshift.com, enter your email and cape as a password, and you will get back your instance. Just by using the URL you see here, it won't work, right? So if I just try to use it in now, it will tell me no access, right? So you have to do it through that login, right? So yeah, that would be one thing. The other thing, you can just go and modify here in work, or you can use the in home. You can use the IDE. I won't open it, but because there are keys inside. But if you want to go to these MVARs and put your own GitHub key and put your own LLM key and whatever, it will be much more specific and much more yeah. And what you have seen right now with this Backstage, maybe it was not clear enough. It's right now this Backstage plugin is part of Backstage because Backstage is deployed right now in the cluster using IDP Builder. In the previous versions of in the previous steps of the lab, we used just a plugin, just a UI without Backstage itself being installed. So it's also possible to do that, right? Well, yeah, it's it's a specific plugin for Backstage, but it can also be used, as Sri mentioned, can also be used as a standalone A2A interface to your agents, right? Yeah, that sums it up somehow. It was a little bit quick to explain or quick to do things. If there are stoppers or blockers. Sometimes it happens that we are putting those SSL certificates on the cluster. Whenever this gets, they get from time to time they get renewed, and you have to rerun this command. If you see something like if you open something in the browser like here and you will see like a certificate not valid or something like that, you should rerun this command. Yeah. So I don't know if there are questions in the chat we have to answer or not. Yeah, and again, all this happening over A2A, and you can have you see a new chat, so you have context. So here, if I ask things, it will know about the history. If I just want to start a completely new chat, I can whether delete that one or create a new one, and it will have a completely separated context, and you can really ask your probably you did not wait enough for everything to get deployed, and if you run this command before everything is deployed, Vault will not be able to not able to access Vault and push the keys, and afterwards it's like not happening what it should. The one thing you can do, so you can, and I'm going to do it right now. So you can use the kind command to just delete the cluster and start fresh and do it again. So you have kin get clusters, for example. You see I have one cluster called local dev, so I will do kind delete cluster, name local dev. And I'm just erasing the cluster right now, right? So you can just go back, and this is done for you already. So just just start the deployment again, right? If some step again, the one tricky thing is really to wait. Where was it? To wait here to see the backstage pod, not the backstage dependency pod, the backstage pod running. That means that Vault is there, everything is there, because that's the last one, right? So if you just continue the lab before this is happening, you might end into problems. So you can just go back, delete the cluster, and go back to this step, deploy again, and start fresh, right? So it's so easy, right? So it's like, right now I have no cluster here anymore, and I can start fresh if I want. I just modify something. I want to add a new application. I don't do anything, and I have everything, everything deployed for me, from Git to Backstage to Argo CD to Keycloak to everything. So, yeah, that would be it. I don't know if we have some end comments or some questions or some problems we can discuss.
I just posted the feedback link for two people to give us feedback. Would love that. Yeah, thank you for posting this on chat.
Yeah, the last thing I wanted to say is that, IDP Builder itself is part of the Canoe initiative, which is, Cloud Native Operational Excellence. You can just go and search for it, and you will see here in more details what the implementations are, what the stacks are that we are using, and so on. The one with Cape, what are we doing on top of it, and these kind of things, right? So everything is open source, everything is out there. So yeah, thanks.
Stefan, I'm going to take this share for a second.
Sure.
We did have a question on IDP Builder. We can address that and then move on to the conclusion. So I think there is a question how if an IDP builder can be run on a local cluster or a remote cluster. Technically, there are no. So the IDP builder is set up as a reference utility to learn about Backstage and other CNCF like tools that Stefan showed, like Argo CD, Argo Workflows is in it, Vault, and Backstage, and Git and few others. There is another AWS EKS reference implementation if you're interested in that, or there is another community members who wrote one for Azure. I think there is GCP in works. Those are probably more suitable for remote or cloud-based deployments. Really, IDP Builder is more for understanding Canoe stack and learning. But in reality, the stack itself is a collection of Argo CD application custom resources. So you can look at that and inspire from it and look at how the Argo CD setup is done. So Stefan, would you like to add anything to that?
No, but I think, deploying a real cluster is also, you can use Helm charts to deploy whatever we have. And again, there are two ways of doing it. Right here is like more of a try and fail way of doing it. So with Docker Compose, with IDP Builder and so on. For production environment, you use Helm charts, and that would be my advice.
Awesome. I know there may be still a lot of questions, and you have plenty of time for you to try out the lab. I want to conclude with this. So we have the community. It's a community project. We meet every Monday. So 10 a.m. Pacific time, noon Central, and if you are in London, it's at 5 p.m. So we would love for you to join those meetings, and if you have any questions, reach out to us there. And also there is a community Slack channel. If you are in the CNCF Slack, this is hashtag Canoe SIG Agentic AI. And there are a lot of good first issues. If you love the project as much as we do, building it and using it, we would love for you to come and contribute. If it's even as simple as writing tutorials, doc fixes, any simple bug fixes, getting started. There are good first issues, and we're also kind of wrapping up that type of community engagement. Sujata posted the workshop survey. We would love if you can give us some feedback on how you like the workshop, the content and delivery, and how you plan to do agentic AI based platform engineering, or do you have any use cases that Cape can serve? With that, we'll leave this page here. I also want to thank all the panelists, Sujata, Hasid for presenting, and Arthur. And we'll hang out here until the end of the session. If there are any questions that we can answer live or on chat.
Yeah, thank you so much, Shri. So yeah, please look at the feedback form. This is how we understand what you are doing, and also if there are any rooms for improvement. And there is also a fun word cloud on, like, what was your key takeaway from the lab. So would love to hear from you about that. And also I posted the link to the GitHub. We would love to have you give us stars. That will help the project. Since, as Shri mentioned, it's an open source project and we all love it. This helps us contribute more as it gets more eyeballs on it and gets us more contributors and maintainers. Okay, let me see if I have some feedback already and I can share some word cloud. Okay, yeah, not yet. So keep those inputs coming, guys. You can see some people are giving inputs, so would love to see what you thought of the session, what are other key takeaways. any way we can improve? I made the word cloud visible to participants. I don't know if anybody can see that. Yeah, looks like people are dropping.
I can see it. I think I logged in as anonymous in incognito window. I'm able to see it, so I think we should be good.
Okay.
Looks like it's a wrap.
Question on chat. Sorry, Harshit. Bypass. I don't know if others saw it.
Was there a question?
General question on team workflow about conflict resolution. Where would we add order of operation checks, for instance, to prevent configuration conflicts?
So multiple things there. So main thing is if you streamline something with good platform engineering, and then add an agentic layer, so that's going to go through the paved golden path, right? So that's this is making it easy to do the right thing, right? So it's almost like agentic AI is helping you get to the right golden path, and also any ambiguities users may have, kind of like clarify those things, because it has the knowledge to go back and forth with the user to clarify that. So that's helping in one aspect. Other things, obviously, this comes to things like human in the loop, where if it is very significant what you're trying to do, and then there are many angles where you can add guardrails and other things. So it really depends on the context. But so yeah, there's a go ahead.
Yeah, I would also add on top of that, you can use a combination of traditional workflows and agentic AI. So I think traditional workflows are not completely dead. So if you build, let's say you have built a lot of GitHub action-based workflows, which in our case we have, or for applying Terraform for doing certain things, and there are guardrails implemented there, it is human in the loop. I think exposing those via agentic AI and being able to provide that workflow conduit to your other deterministic workflow automation tools like Argo workflows, like GitHub Actions or Temporal. Those are still, I think, using a hybrid approach is definitely makes that level of determinism higher. I think, as we described in the session, this is something we are experimenting with in other mass systems. Having a very deterministic plan, like we showed, and be very prescriptive about actions, that can help a lot for a certain type of workflow. If you always tell the LLM you need to follow a strict plan, that's another way to bring up the level of determinism. I hope we actually addressed your question. I hope that was in the same area.
Yeah,
Awesome.
yeah, we did.
Thank you.
Yeah, and that's our time, I think, right?
Thank you all.
Sujata, you want to wrap up? Yeah. Wrap it up.
Yeah, go ahead, Hasit. You wanted to?
No, nothing to add. Like, yeah, thank you all, and folks will get creditly badges, right? Yes.
Yes,
Right.
definitely. Yeah. Yeah, thank you, everyone.
Thank you.
Thank you.
Bye.
Bye.
Thank you.